Hi everyone, welcome back to my channel. So today we'll be going through another tutorial on the Casio Classpad fx-CP400. Today's topic will be on circular functions. Okay, so let's get started. So the passengers on the Ferris wheel access their seats from a platform 5 meters above the ground. As each seat is filled, the Ferris wheel moves around so that the next seat can be filled. Once all the seats are filled, the ride begins and lasts for 6 minutes. The height h meters of Isabel's seat above the ground t seconds after the ride has begun is given by h equals to 15 sine of 10t minus 45 degrees plus 16.5. And we want to use, for part A, we want to use a calculator to sketch the graph of h against t for the first 2 minutes of the ride. Okay, so let's do that. So in order to do this, we need to go to menu. So go to menu and then go to graph and table. And then in the first function, so your y1, you want to type in the functions here, which is basically 15 times sine. So to go to sine, you need to press keyboard and then go to math. So go to math 2, or you can go to math, yeah, go to math 2, yep. Go to math 2 there and then go to sine there. So this is sine and this one. Okay, and then here you've got 10. So instead of t, you want to put x, so 10x minus 45 and bracket and then plus 16.5. So plus 16.5. And the other thing is you want to make sure you're in degree mode, which is just over here. Got the degree there. And then, so if it's not in degree, just press it, cycle it through until you get degrees. And then, so once you type that in, the other thing is you need to put a boundary, like the domain. So to do that, you press on this, which is on math 3. You want to press on this one here, this straight line there. So press on that so you can restrict the domain. Otherwise, you just go on forever. You want to put the restriction on between 0 and 360. So you got the less than equal sign, which is here, this one here. So press on that, and then just put it to, in this case, so the domain, because we want to graph up to 2 minutes, and in the time domain is in terms of seconds, so we want to change it to seconds. So 2 minutes means 120 seconds. So you just put from 0 to 120. So I type that in there, and then just give that a tick and press on the graphing button here, this one. So press on that, and then you'll start graphing. So if you don't get a graph straight away, that means your windows needs to be set up correctly. So how you do that is you press on this expansion thing here, this symbol here. So press on that. And then what you want to do is your X minimum should be technically from 0 because time can't be negative. But I'm going to put -10 anyway, so I can see the graph better. And then your X maximum should be 120 and above. So I'm going to put 150 again to see the graph better. The scale and dot, you can leave it as per normal or as per default. And then your Y minimum again should be from technically from 0 because height can't be negative, but I'm going to put -10 anyway. And then for Y maximum, it technically should be 31.5 because it's the amplitude plus the translation, which I'll show you in a bit. But I'm going to put it to 35, and the rest of the settings should be fine. So you should have the settings set up like this. So that's the X here and the Y there. And the rest can be in terms of default. And just press OK there. And then you should get a graph like this. Okay. Then the next thing you want to do is you want to know what the y-intercept is. So to do that, you just go to analysis gsolve. Oh, sorry. You go to analysis and trace. So analysis trace. And just put x equal to 0. So just put 0 here. So when you press 0, this thing will pop up, enter value, and just press OK once you put 0. And there you have it. So your y-intercept is at 5.89. So yeah, so that's all we need to graph this to do this graph. So the other thing you want to know is what's the minimum and what's the maximum. So to do the minimum and maximum, you can either use gsolve or you can just work it out from the function itself. So your minimum should be 16.5 minus 15, and then your maximum should be 15 plus 16.5. So how that works is I'll just quickly reshare my screen here. So let's quickly graph this out. So for part A here, we've got basically, so like this, we just copy it from the CAS calculator. So this is in terms of seconds, and this is in terms of meters. And so our initial height is basically 5.89. And then this one should be 31.5. And where did I get 31.5? It's 16.5 plus 15. And then for the minimum is 1.5 because that's 16.5 minus 15. And then if you copy from the calculator, you should get a few cycles. So you should get like one, and then you got two, and then you got three, and then up to here. And that's the endpoint here at 120. And if you want to find the endpoint, that's pretty easy. You can just go back to the calculator, and then you use trace again, and then you just press 120, and then press OK. And once you do that, you should get 30.99 on the calculator. So this would be 120, comma 30.99. So if you still don't get that, let me know in the comments down below, and I can show you that. Okay, so that's part A. That's all done. And then part B is how far above the ground is Isabel's seat at the commencement of the ride. So in this case, when time is equal to 0, then the height is 5.89, which is basically the y-intercept here. So we can write our answer straight away is 5.89 meters. How many seconds does Isabel sit past the access platform? So access platform is 5 meters. So what we want to do is we actually need to create another graph, and it's just a straight line graph of height equals to 5 meters. Whoops. So we just do another graph here where it's 5, and it's just a straight line graph where it's just going to cut across the circular function a few times. And we want to find what is the first intersection point between the two graphs. So it should be here. So it will be whatever this time is, so I'll call it T1, which we'll find it from the calculator, and the y coordinate will be 5. So that's the first intersection point between the two graphs to give us the answer for part C, which is after how many seconds does Isabel sit past the access platform? Okay, so let's go ahead and do that on the calculator. So we go back to our graphing page like this, and then for y2, we just put 5. So nice and easy, and just give that a tick. So you should have a graph popping up. Let's see. So if we do, oops. So if we graph it out, so yeah, so you have to refresh the graphing. So basically you have to repress this one here, this one, so you can get two graphs like this. And then you just press on the graph again with the stylus, go to analysis and gsolve, and then go for intersection. And then it's just loading, and there you have it. So the first, how long does it take to go past the axis is 27.5 seconds. So we can write that in. So it's 27.5 seconds. So 27.5 seconds. So after 27.5 seconds is when the Isabel seat passed the access platform. So the next question is, how many times will her seat pass the access platform in the first 2 minutes? So that's pretty easy. If we look at our graph here, we just need to count how many times does the red line crosses the blue sinusoidal line. So you can see there's 6 times. It crosses 6 times. So we can write that in to our answers there. So how many times is 6 times? And the next one is part E. So how many times will her seat past the axis platform during the entire ride. Excuse me. So in that case, we want to extend our domain. So this one here where I'm highlighting. And 6 minutes is equivalent to 360 seconds. So let's just go ahead and do that and just press execute. The rest is the same. And then, so in order to refresh your graph, you need to press that again. So just press that again. So now it's going to do its graph again. But notice this time our window is not big enough. So you can see it's been cut off. So what you want to do is you want to press that expansion bracket, this symbol again. So pressing that. And then in this case, again, we need to reset our basically our window. In this case, X minimum, I'm going to put -10. Technically, it should be 0. Again, I just want to see the graph better. The X maximum should be more than 360. I'm going to put 400 so I can see the graph better. Scale and dot just leave the same. Y minimum, I'm going to put -10. And Y maximum is 35. And then just press OK. And then just let it graph. So you should get more of the sinusoidal and the straight line will still be the same. And in this case, to answer this question, how many times will a seat pass the axis platform during the entire ride? You just need to count how many times it crosses the blue line. So the red line crossing the blue line here. So I'll just quickly show you. Yeah, so that's that. So we want to find out how many times it crosses that. So if you count that, you're going to get 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. So you should get about, in this case, 19 times. So you should cross about 19 times. So let's go ahead and write that. So it should be 19 times. Okay. And then the next one is, so due to a malfunction, the Ferris wheel stops abruptly 1 minute and 40 seconds into the ride. How far above the ground is Isabel stranded? So in this case, we just need to use trace, so analysis trace, and just type the X coordinate as 100. So just type 100 like this, and go 8, okay. So basically when t equals to 100 seconds, your height is at 4.21 meters. We can write that in. 4.21 meters. Okay, so for part G is a bit more tricky. So what I'll do is I'll just share my screen here. Okay, so for part G, we need to basically have a new function. So right now, our h is equals to 15 sine of 10t minus 45 degrees plus 16.5. But because the question here is, if Isabel's brother Hamish had a seat 1.5 meters above the ground at the commencement of the ride, so basically the y-intercept is 1.5, how far above the ground is Hamish stranded? So we need to have a new function. We can call this g equals to 15 sine of 10t. We just call this plus a. So it's our phase shift, and then plus 16.5. And in order to solve for a, this should be equals to 1.5. So the reason it's 1.5 is because the coordinate point is 0. When time equals 0, Hamish is at 1.5 meters above the ground. So then we just need to use the solve function on the calculator to solve for a. So let's go ahead and do that. Okay, so what you want to do is you go to menu and go to main. So press on that and then go to, in this case, you can do, let's see. Okay, so what I'm going to do is go to keyboard, go to math 1, and go to solve. So you can see a solve there. Solve there, so press and solve. Make sure you have it in degrees here. And then you just quickly type the expression in. So you've got 1.5 equals to 15 times sine. So sine, you can just get it from math 1 and then just do 10. Oh, sorry. So Because time is equal to 0, so 10 times 0 is 0. So don't worry about 10, 10t. So in this case, you just put A. So instead of A, I'm just gonna put Z, and then and bracket, and then plus 16.5, and then put comma Z because you want to solve for Z and bracket. So and then you need to put a restriction on the domain. So to do that, you can go to Math 3 and go for the straight line here. So you can see there, straight line there, and that's the symbol there for restriction on domain. This one, yep. And then just do 0 less than equals to Z less than equals to, in this case, should be between 0 and 360, like this. So the entire function, so solve here, 1.5 equals to 15 times sine of Z plus 16.5 comma Z, solving for Z, where Z is between 0 to 360. And then just press execute, and you get Z equals to 270. So that is our phase shift. And then, so I'll just quickly share back my screenshot here. Okay, this one here. Cool, okay. So A is basically equals to 270. So then our new function is g of t is equals to 15 sine of 10t plus 270, and then plus 16.5. So that's our new function. And then now we need to go back to our calculator and type in our new function. So go to menu, graph and table. And then now we need to go to Y3, our third function, and we need to do 15. Or you can just highlight it from the top there, and then just go copy. So highlight the first function, copy, and then just do edit paste, edit paste. And now instead of minus 45, now you can put plus 270 because our A was 270. The rest can be the same. So between 0 and 360, that's fine. And then you just tick that, and you can actually you can untick the other two because you don't really want to see the graph stay. You just want to look at graph 3 and then just regraph it, refresh that, and just let it graph. Okay. And then you just want to go analysis and trace, and you just do 100 because that's when the first wheel stopped, malfunction. And there you have it. So the answer is 13.895 or 13.9. So Hamish was stranded at 13.9 meters above the ground. So then that's it. So that's the last question there. If you got any questions about this, let me know. Otherwise, I'll see you in the next session. Okay, see you later.